Well, hello everybody. Today I'm going to be showing you how to find the distance between two parallel lines. And we're going to do it graphically, and then in a second video we're going to do it algebraically. So we're going to start off by doing it graphically, and graphically we're going to show how to use both the Pythagorean theorem and the distance formula. Alright, so let's go ahead and get started. The first equation we are going to graph is y equals 2x plus 7. And then the second one we're going to graph is the line that is parallel to it with the same slope of 2, but a y-intercept of -3. So we have those two lines and we want to find the distance between them. Now, as you know, you can draw lots of different segments between those two lines, but the only one that represents the distance is the shortest segment, which is found by using the perpendicular segment. And of course, there are infinitely many of those as well, and we can go from any point on one line using the perpendicular to get to the other one. I'm going to go ahead and recommend that you use the y-intercept. So I'm going to go ahead and choose the y-intercept on this red line and put a point at 0, -3. Well, as you know, the slope of each of these two lines is 2. Slope of that line is 2. The slope of that line is 2. And the perpendicular slope is going to be the opposite reciprocal. So what is the opposite reciprocal of 2? That's right, it's -1/2. So normally, if we were going to use a slope of -1/2 starting at this y-intercept, we would go down 1 and over 2, and then we do it again, down 1 and over 2, and of course we could do that forever. Problem is, I'm moving away from the other line instead of moving towards it. So I'm going to go ahead and go the other direction instead. Instead of going down and right, I'm going to go up and left, which of course is the same slope of -1/2. And when I do that, conveniently, I intersect my other line at this point right there, which is -4, -1. And now I can go ahead and make that segment connecting those two. And that distance there represents the distance that I need, the distance between these two parallel lines. So let's go ahead first and find that distance using the Pythagorean theorem. Of course, the Pythagorean theorem requires that you have a right triangle, which is not hard to make. There's my right triangle. And then I can go ahead and find these distances. Of course, we shouldn't need to measure them to find them. From there to there is 2 units, that is the vertical leg, and from there to there is 4 units, that is the horizontal leg. And of course the distance we're trying to find is from there to there, which turns out to be approximately 4.47, which we're going to find exactly using the Pythagorean theorem. So again, there's our distance, 4.47. There's that distance, that is 2. And that distance, that is 4. All right, so let's go ahead and find that exact distance using the Pythagorean theorem. Of course, you recall that the Pythagorean theorem says a squared, one of the legs squared, plus the other leg squared is equal to the hypotenuse squared. We're going to go ahead and use this side as A, this side as B, and of course you always must make your hypotenuse C. All right, so here we go. So we have 2 squared plus 4 squared equals C squared. Well, 2 squared is 4, 4 squared is 16, and 4 plus 16 is 20. So 20 is equal to C squared, but we're not interested in C squared. We want C, so we're going to take the square root, and C is the square root of 20. So the actual distance here, which they have labeled CA, which of course is that distance, is the square root of 20. Now, many times we like to express square roots in a simplified form. So the square root of 20, if you're interested, we could rewrite it as the square root of 4 times 5, because that's what 20 is. But what is the square root of 4? It is 2. So we can rewrite this as 2 times the square root of 5. So that is the exact distance between these two parallel lines found using the perpendicular slope, which connected us to the other line, which got us this point right here. Found that distance of that segment by making a right triangle and using the Pythagorean theorem. Of course, we could also use the distance formula. So let's go ahead and get rid of all of that stuff there. I'm going to go ahead, in fact, and eliminate the triangle. Gone. Let's get rid of all this stuff here. Whoa, too far. Let's bring those lines back. All right, and we once again are going to bring back the segment as well. I went way too far on my deletion. Okay, now we're back. All right, so now I have this point right here and that point right there, which we already had. But when we did the Pythagorean theorem, we weren't focused on the coordinates. But now we need the coordinates. So this coordinate is at 0, -3. And this coordinate right here is at -4, -1. So now we're going to use the distance formula, which, as you recall, hopefully, is the square root of, it's actually just the square root of the Pythagorean theorem. So you can either do x1 minus x2, it really doesn't matter, x2 minus x1 squared plus y2 minus y1 squared. Now what is this x2 minus x1 squared? It represents that vertical distance that we had when we had the right triangle there. And this y2 minus y1, I said that backwards. The x2 minus x1 represents this horizontal distance, which you recall we said was, do you remember what it was? It was 4. That is my x2 minus my x1. And then this distance right here, which was 2, that is my y2 minus y1. All right, and there's our right triangle we had in the Pythagorean theorem. But we're going to do it pretending we didn't know. So my x2 minus my x1, I'm going to go ahead and call this point right here x1, y1, and then this one is going to be x2, y2. So if I do x2 minus x1, the way I wrote it, that will be 0 minus -4. 0 minus -4. And then we have to take that answer and square it. Well, subtracting a negative, same as adding a positive, we get 4 squared, which is 16. Plus, then I'm going to do y2 minus y1. Again, the way I wrote it, y2 is -3. And my y1 is -1. And again, I have to square that. And once again, subtracting a negative, same as adding a positive. 3 negatives plus 1 positive gives me 2 negatives squared is 4. And I get 16 plus 4. Of course, all of this is under the square root. All of these are actually under the square root. Gets kind of crowded there. And I get the square root of 20, which you recall is what we had earlier, which we simplified to 2 root 5. So using the distance formula, we get the same distance, the square root of 20. So that is how you find the distance between two parallel lines graphically using either the Pythagorean theorem or the distance formula to find the distance.